Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at an example of derivatives and particle motion. So just working through some questions about a particular particle motion problem and what we can glean. So let's say we have the function s of t equals t squared minus 7t plus 10, which describes the motion of a particle along a line at any time for a positive t. Find the velocity function of the particle for any positive t. Well, we know that for particle motion, the derivative of position is velocity. So if I have my position function s of t, then my velocity function will be s prime of t, or 2t minus 7. Okay, pretty easy, but we're setting ourselves up for the next question. Using that same information and our derivative that we just created, let's identify the time interval or intervals on which the particle is moving to the right. Then, when is it moving to the left? Well, here we need to think about moving along a line. Okay, so if we're going left to right, velocity that is positive moves us to the right, or if you were thinking about like the x-axis, it would move us in towards the negatives, and velocity that is negative moves us to the left. So we're going to be looking here for where is our velocity positive? That's when we're moving to the right. And where is our velocity negative? That'll be when it's moving to the left. So first we need to figure out where is the velocity equal to 0? Well, solving this, I get t equals 7 over 2. So I can think about working on a number line. Typically, our number lines extend from negative infinity to infinity, but here we're only working with positive t values. So we have a value of 0, and then we have you can think of that as a critical value of 7 over 2. So if I were to take a value between 0 and 7 over 2, let's say maybe 1, and plug that into my velocity, 2 times 1 would be 2 minus 7. That would give me a velocity that is negative. Plugging something in greater than 7 over 2, well, let's see, 7 over 2 is about 3.5, so maybe let's plug in 6. 2 times 6 is 12. 12 minus 7 is a positive value. So we can say that the particle is moving to the right when velocity is greater than 0 on, our interval here is from 7/2 to infinity, and it is moving left when the velocity is negative, and that is occurring on the interval 0 to 7/2. Okay, so the particle is moving to the right from 7/2 to infinity, or whenever velocity is positive, and it's moving to the left whenever velocity is negative, or 0 to 7 over 2. Also, we might want to note that that means at time equals 7 over 2, our particle changes direction because it goes from moving to the left to moving to the right. So it has to stop and kind of change. All right, for this same question, let's find the acceleration function. So we already went from position, we took the derivative and got to velocity. If we take the derivative again, that will get us to acceleration. So just copying over here, we had 2t minus 7 was our velocity function. So our acceleration function will be the derivative of velocity, which will just be 2. Okay, cool. So our acceleration function is 2 for any time t greater than or equal to 0. Okay, so using that information, let's figure out when is the particle speeding up and when is it slowing down. All right, so to think about speeding up and slowing down, speed is actually not the same thing as velocity. Velocity includes direction. So when we talk about speeding up and slowing down, we're actually looking at a combination of velocity and acceleration. So just like velocity has direction, right? We just looked at velocity. If we're moving to the left, then we have velocity is negative. And we're moving to the right whenever velocity is positive. Well, acceleration is change in velocity, right? So if we have positive acceleration, then we are kind of moving more quickly in the right direction. So we are accelerating to the right. And if acceleration is negative, then we are accelerating in the left direction. So if you kind of think about these forces working together, anytime that you are moving to the right and accelerating to the right, those two forces would be working together and you would be speeding up. The same thing would be true if you were moving to the left and also accelerating in the left direction, you would be speeding up. So speeding up is going to happen when acceleration and velocity have the same sign, whether that's both positive or both negative. Now, if those two forces are working opposite of each other, so let's say we are moving to the right, but accelerating to the left, those two things are opposing each other, so that's going to cause us to slow down, or vice versa. If we're moving to the left, but accelerating to the right, then that's going to work against each other and we're going to be slowing down. So this happens when acceleration and velocity have different or opposite signs. So for our little particle, let's figure out what's happening. Well, we had 7/2 as our critical number for velocity, and we found that we were moving to the left between 0 and 7/2, and then we were moving to the right after that. Now remember, from the last screen, our acceleration function was 2. So 2 doesn't give us any critical numbers. Our acceleration is constantly positive. So on both of these intervals, acceleration is positive. So to figure out if we're slowing down or speeding up in either of these intervals, we just look at the combination of the signs for velocity and acceleration. On the interval from 0 to 7/2, because velocity and acceleration have opposite sign, your particle is slowing down. Okay, in this case, it's moving to the left, but accelerating to the right, so those forces are in opposition. And from 7/2 to infinity, because the velocity and acceleration have the same sign, our particle is speeding up. It's moving to the right and accelerating to the right, so those forces are working together to speed the particle up. All right, guys, that does it for this video on derivatives and particle motion. We'll catch you in the next one.